Yeah, would like request you to turn off your mobile phone or try put it on silent mode, please.
Good morning, everyone. To start with, I would like everyone to give 2 minutes of tribute to our youth icon, departed Dr. Puneet Rajkumar.
I request all the audience to stand up. Observe a minute of silence.
Hello check. Hello check. Hello check. Hello check. Hello check. Hello check. Check. Hello.
So I would request all of you to stay silent for 2 minutes so that we can pray for the departed soul. Peace.
Mostly are they echo.
Good morning, everyone.
Acharya.
Thank you to each and every one of you for being with us and being a part of the Building Information Modeling talk today. I, Akanksha, on behalf of RNSSA, would give you the heartiest welcome and would like to welcome our dignified dignitary, Mr. YC Lakshmi Prasad Sir, Honorable Principal Sir, Vasant K. Bhatt Sir, respected faculties and all my fellow students present over here.
ನೀನು ಜಾಸ್ತಿ ತಲೆ ಕೆಡಿಸ್ಕೊಂಡು ನೀವು ಜಾಸ್ತಿ ತಲೆ ಕೆಡಿಸ್ಕೊಳಕ್ಕೆ ಹೋಗ್ಬೇಡ ಡೈರೆಕ್ಟ್ ಆಗಿ
We hope all of you get to learn a lot today. Now, I would request Medini to give the welcome song for the day.
ವಿನಾಯಕುನಿ ವಲನು ಬ್ರಹ್ಮವೇ ನಿನ್ನು ವೀಣಾವೆಲ್ ಪೊಲೆವ ರಮ್ಮ ವಿನಾಯಕುನಿ ವಲನು ಬ್ರಹ್ಮವೇ ನಿನ್ನು ವೀಣಾವೆಲ್ ಪೊಲೆವ ರಮ್ಮ ವಿನಾಯಕುನಿ ವಲನು ಬ್ರಹ್ಮವೇ कामाक्षि अनाथरक्षकि श्रीकामाक्षि सुजनागमोचनि शङ्करि जननी सुजनागमोचनि शङ्करि जननी विनायकुनिवलेनु ब्रोववेनिन्नु वीणावेल्पोलेव रम्म विनायकुनिवलेनु ब्रोववे.
Thank you, Medini, for the beautiful song. So now talking about our chief guest, our very honored chief guest, architect Lakshmi Prasad sir. He graduated from UVC and soon after he set up his consultancy in Bangalore and Dubai. He has designed a wide variety of projects internationally. He is an expert at BIM and has volunteered to give us a brief intro on BIM and its relevance to all of us, the architects. So a huge round of applause for him. Thank you, sir. Thank you, sir, for honoring us with your auspicious time. Now, I would request respected principal, sir, to hand over the token of welcome to Lakshmi Prasad, sir. So, to begin with the program, we are pleased to have Lakshmi Prasad, sir, to deliver the opening remarks. Over to you, sir.
Laptop. Good morning, my friends, my future fraternity, future architects, the faculties. I would like to thank Mr. Vasant Bhatt for giving me this opportunity to share my experience for the past 30 years of practice and also my experience with BIM, which I have recently learnt. I would like to also bring the name of my great friend Harun Salim, whom both Mr. Vasant Bhatt and Harun Salim I know since 1979. To start with on a lighter note, Harun Salim was the one who ragged me when I went to college in 1979. He's a very good ragger. Hope he doesn't do to students. But he is the best friend of mine always. We have become very good friends as per the expectation of ragging. The purpose of ragging is to become close for the younger generation, for the first year students who come. And that has served. Till now, 43 years, I have been a good friend of Harun. And of course, our Vasant Bhatt was one of the best person, very decent, very straightforward, and always helping people and motivating the juniors. I am junior to both of them. My friends, the 35 years of practice has not been so easy. It was not that everything went right, everything went wrong in fact, but I pursued my interest in architecture, in interior designing, and now to sharpen up my service as a consultant, I have learnt BIM. Where I have learnt, how I have learnt, everything I am going to share it with you. So to start with, I would like to, because you are going to bombard me with a lot of questions after the session, which I am going to run through as fast as possible because Mr. Vasant Bhatt has asked me to complete everything in 1 hour. So these are the questions which I would like to start with. Please try to answer as fast as possible. Which are the other sciences related with architecture? Can anybody answer this? Which are the other sciences related with architecture? Social science? Okay. You can check on Google, there is a direct answer on this. You will know which are the subjects which are related with architecture. Who are the stakeholders with you in the profession? See, we came from an era wherein we used to prepare drawings by hand, pencil, rotring pen, then we became AutoCAD, and now we have come to something else. But when we were designing it by hand, we were the bosses. We were the people who used to prepare all sorts of drawings. Now it is not so. We are not. We are one of the stakeholders in a group of experts to design a building. So who are the stakeholders with you in your profession now? Structural engineer comes next, MEP consultants, then safety consultants, interiors. Okay, I think what are the different type of projects in which you will be involved in future? What do you think you will be responsible to in your profession in the future? It is not just being an architect. There are other responsibilities which we have to take. And what are the different types of projects in this? What are the different type of projects which you will be handling in your future? Can you name a few? Backbenchers, I am very much direct. Please answer the question. The one who, please answer the question. What are the type of projects in which you will be involved in future? Please stand up and answer. I am trying to make this quite interactive and neat. What are the different type of projects in which you will be involved in future? Can you be a bit louder? No. As architects, what are the different type of projects in which we will be involved?
Infrastructure projects like airports.
Yes. Yes. Ports. Anyway, what are the different roles that you need to be responsible in future? You are responsible as architects, but what are the other roles that you are going to play being an architect? Okay, I think you will be able to answer these questions at the end of the session. Okay, this is a very famous terminology SDG. What is SDG? What is SDG? Faculty can also answer the question. SDG. Goals. Yeah, okay, good. And you will all be responsible, you should note that you will all be responsible for SDGs, the 17 SDGs. Now I ask you the direct question, what do you think about BIM? What do you think is BIM? What do you think is BIM? Building Information Modeling. Okay, what is it actually? Correct, almost you are correct, almost. What could be the relation between BIM and architecture? What could be the relation between BIM and architecture? All of you should participate. Whatever you think, even if it is wrong, it is okay, because end of the session you will know what it is. What could be the relation between BIM and architecture? Can you define what is AECO? AECO. What is AECO? What is AECO? AECO is Architecture, Engineering, Construction and Operation. We are going to be responsible from architecture to operation. That is BIM. That is what we are going to know. I am going to now play a video which will define what is that we are going to talk of. Sound. ಅವಾಗ ಬರ್ತಾ ಇದೆ. ಅವಾಗಲೇ ಬರ್ತಾ ಇದೆ.
Disruption is all around us. Disruption.
Full ಇದೆ. full ಇದೆ. ಅವಾಗಲೇ ಬಂದಾಗ್ತದೆ ಆಗ್ತದೆ.
Disruption is all around us. We have more data, means of communication, and computing power than ever before. There's an explosion of technology impelling the job site into a new era. Imagine the possibilities that exist for transforming the business of construction. This is the future of making things. Autodesk led the shift from the drafting table to the computer screen, launching the era of documentation over 30 years ago. Advances in digital technologies led to building information modeling and the era of optimization, where projects can be visualized and simulated before breaking ground. Today, mobile devices, the power of the cloud, and big data are changing everything and ushering in the era of connection. In this new era, the boundaries between design and build, planning and execution, construction and operations are disappearing. In the era of connection, BIM, Building Information Modeling, improves predictability and reduces project risk by putting data at the center to connect teams, insight, delivery, and assets. Data in the cloud brings together designers, contractors, and subs and puts information at the center of the project. Connected teams stay in sync from the office to the job site and can quickly resolve issues and improve outcomes. Connected delivery extends digitization to the construction site, facilitating work efficiency, quality, and safety. Design intent is translated into flawless execution that saves time and money and reduces risk. Connected Insights captures, creates, and computes enormous data sets to align planning to performance. Stakeholders can also learn from operational data gathered across the entire project lifecycle. With connected assets, operational data is collected and made available from construction through ownership to prioritize maintenance and plan future improvements. Welcome to the next era in construction, the era of connection, where BIM forms the foundation for success. Are you ready? This is the future of making things.
This is a brief introduction to what we are going to discuss now. What I am going to highlight as BIM, which is a very, very important subject which is going to take all of us by storm, because this is going to change the methodology of handling projects. This is going to, this is a very important part of our profession, wherein we are just trying to understand what is BIM so that our future will be totally different from what it was. This is what I just felt when I learned BIM. So this is the life cycle analysis in BIM, wherein from conceptual stage, then we go to the detailed design, then analysis, documentation, fabrication, and then construction details, and then construction logistics, operation and maintenance, and then it goes to even demolition. So the design team headed by the architect will have to even think about the demolition at the end when he designs the building at the earliest stage. The lifespan of buildings, which all of you know, could be about 5-6 decades now, but we have buildings which are more than 500 years also, but still they have not followed any technology, but still they are there. They're still good. They're still iconic buildings. But what we have been doing now in our profession is all temporary structures compared to the iconic structures. We are designing it for maximum 2 generations and at the most for 3 generations. At least to that extent, the building has to be efficient. For that, the role of architect will start and then it will end at the demolition. The role of architect is not just to design the building and forget it. It is to ensure that the entire lifespan of the building is properly taken care. So now I would like to design BIM. BIM is a set of technologies, processes and policies enabling multiple stakeholders to collaboratively design, construct and operate a facility in virtual space. This is the definition that we find from RIBA 2018 or BIM dictionary which was published in 2018. Manual drawing was the language of our industry. That was our era when we used to prepare drawings by pencil, rotring pens. Then we came to CAD. Then now it is BIM. RIBA is the one which initiated the discipline of BIM, the part of Royal Institute of British Architects in 1963. In 1963, initiated the discipline, initiated how the building has to be designed, how the design has to be documented, starting from design stage, data collection. Technologies that are related to BIM. These are the technologies that are related to BIM. 3D printing, feedback, IoT, drone, construction, automation, laser scanning. These are all the technologies that are a part of BIM. BIM is very, very late in India. In India, we have not even made a humble start. We have not even entered, but still, BIM, we are the factory for BIM. We are the people who are producing maximum number of models related to BIM in India, but still, our government, our institutions have not taken up this BIM as a serious subject, as a subject which can transform not only us, but also our complete nation. Our society can be changed by BIM, by delivering projects which are really of high quality. We are talking about net zero buildings, net zero projects, and the environment effects on these by these projects. What we have done up to now has been totally temporary structures. I'm very sorry to tell you this, compared to whatever is happening in and around this country, there is only one thing, that is the least cost, wherein the project is completed, and whether it is properly maintained, whether it is properly monitored, whether it is properly used, is not the botheration of the design team. But this BIM is a foolproof system wherein from the design stage up to the asset management stage, everything is black belt. Everything is properly monitored. Everything is properly validated by experts. Everything happens on a single environment wherein everything is under control. Then I think such projects for our nation, for the whole world, will be very, very useful, and the present structures are also to be validated, are also to be upgraded. The value engineering has to be added to the existing building, which has to start. The government buildings are to be the first target. Unless and until we do this, we will not be able to maintain a good ecosystem, at least in our nation. India will become something like Calcutta, which is going to be very, very unfortunate. See, countries, with about 50 to 60 countries, all around the world have made BIM mandatory. Why it is not made mandatory in India? Why it is not taken up seriously is something which is questionable. A country like Gulf, wherein I practiced in Abu Dhabi, it was mentioned that I practiced in Dubai, I practiced in Abu Dhabi. A country like UAE has made it mandatory. UK has totally made it mandatory. Australia, New Zealand, Singapore, all these countries have made it mandatory. Almost 50 to 70 countries are following BIM, but unfortunately we are not serious. These are all the different stages which are going to be defined, and at every step the architect is responsible. He has to monitor at every stage. RIBA stages, that is Royal Institute of British Architects discipline, says first is the strategic definition. What is going to be the project? How the project has to be executed? What is the dimension of the project? Everything is defined by a group of experts who will guide the clients as to what can we expect from the project according to its requirement. Then we prepare a brief, a project brief, which is called the Employer's Information Report. Then after that is prepared, we go to the concept stage, then the spatial coordination, then the technical design. Technical design includes structures, MEP, air handling, safety, and all other related issues about the project. And then comes the manufacturing and construction, because there is a lot of material involved in the project. There is lot of material which has to be properly specified, which are to be properly used. Okay. Hello, am I audible? Where? Audible? Hello? Yeah. Hello? Then the responsibility is not stopped by completing the project. Then it goes to the handover. After the project is properly executed, it is handed over to the facility managers. Facility managers will try all that is required on the project. Facility managers will put value engineering as a priority. They will ensure that every utility services, every part of the project is properly defined, it is properly operating. Then the project is handed over to the asset managers who will manage the asset. As they have the complete details, they will be able to use it much better than just handing over the project. These are all the project stakeholders. When I was practicing in Abu Dhabi, I was part of a group wherein there were 70 stakeholders, not 16 which I have listed here, because this is for our immediate requirement I have listed. I would like to share my experience of practice in Abu Dhabi here, wherein before we used to start the project, before we used to even put pencil on the paper for designing our sketches or whatever it is, we used to have a committee. The committee which should be listed, and it was supposed to be handed over to the municipality. Once it is handed over to the municipality, so I was telling you, I was sharing my experience in Abu Dhabi when I was practicing. Before we start the project, a structural engineer, a quantity surveyor, a sustainability expert, and life cycle analysis expert, safety expert, MVP expert, all these people used to be on the committee. Used to submit this report for approval to the municipality. including the contractor. 3 contractors used to be in the panel before we start the design, because they used to contribute, they used to talk practical aspects before we design and decide the project. That same system is asked in BIM also. There we used to follow Istadama, like all of you are used to follow, or used here to follow Gruha or Reel. So that was one of the basic requirements, because the days were gone that architect used to take all the decision on his own. Starting from the conceptual stage, every aspect of the design, every angle, every detailing, every practical aspect would have been considered before the design is finalized. So we have to learn to work with the stakeholders, to work with the partners, to work with the different experts. We were preparing ourselves, me and Salim remember that we were preparing details, we used to prepare ourselves. Now it is not like that. Architect will do his job, structural engineer, even structural detailing architects used to do. I myself used to do. Sometimes when we could not afford to pay a structural engineer, we used to detail it out on our own with our practical experience. And whatever it is, now it is not so. There should be a designated structural engineer, an MEP expert, an air handling expert, a safety expert, a quantity surveyor, a sustainability expert, and whoever is there, he has to give his report, written document, drawings, detailing, everything, and that will be validated, that will be approved by a third-party expert, maybe sitting in different part of the world, maybe in Europe, maybe in US. We have to take the expert's opinion before we finalize anything. So projects, we have to learn as architects to work with different experts on equal terms. So when this is the key strategy, this is according to me the one which defines, the one which makes things possible to make the building design most efficient and to make the building properly getting executed, properly maintained, and properly enjoyed by the user. This is the common data platform. Common data platform is something which I don't want to go into details because it is very much technical, wherein it's a platform wherein all the stakeholders of the project, owner, architect, engineer, contractor, and operator, whoever is involved is totally informed on the common data platform. He is given the lead to the data which are related to him, and sometimes all the data are also given to them for proper understanding of the project. So this is, according to me, the key strategy which can make the building design foolproof and then the execution. And I don't want to again go into the details of the software involved. It is subjective. You people can select on their own whichever software they are convenient with, whichever software their stakeholders are using, whichever software is absolutely economical. So this is something which I would like to explain at the end. Data collection, I think this list you can get it from Google. If you Google, you will know for what you have to use which software. But software or some of the softwares involved are not as complicated as the one in which all of you are real experts. All of you, I know very well, can do 3D Max, can do various softwares, and this is nothing bigger than that, or this is nothing more complicated than that. Please understand that BIM is something which is as a strategy will work and which is not difficult at all. We have to take it easy. You have to understand there is no other go. There is no other methodology for the future which can ensure net zero buildings and the efficient buildings in this world. And India or the whole world cannot afford anything which is temporary. Anything which is not of quality, it is not possible to accept. So considering these softwares you will have to master. And what we have to do, I would like to explain next. See, this is how the BIM, I think, originated. See, this is as simple as a tree without leaves during, I think, February or maybe January. So wherein the tree is without any details, the tree has got basics and the tree doesn't have any details. Going to the next aspect, LOD 200, we call all these things at different level. LOD is level of detailing. Level of detailing is something which is standardized in different countries with different standards. But this is the idea behind this methodology of building information modeling. LOD 100 is without any details. LOD 200 is with schematic design. And then LOD 300 to 350 is detailed design, because this would have been cross-checked from architecture to security. Architecture, structures, MEP, then security, and all other aspects are totally covered, and this level of detailing is at 300 to 350. Then it is level LOD 400, because this is with quantity and time scheduling of the project. This comes during the execution of the project. And then LOD 500, when we complete the project, we prepare as-built drawings, we prepare the reports, we prepare the complete data required and put it on the common data platform for people to understand, for people to take over, for people to use, for people to edit, for people to understand. So this is the idea. This is how we fit the data. We play with the data here. We create the data, we manage the data, we edit the data, we modify, we fine-tune it to ensure that the design, the execution, the maintenance comes at a proper level of at least to some standard, wherein the building becomes self-sustainable and can be called as net zero. This is the path towards bringing out net zero projects in this world. Again, this is almost the same which I have just explained to you, and these are all the different levels, and further I am going to detail out what are the other aspects within this detail. Before we take up the project, it is not that we just we have the site dimension and we create some sketches and we say that these are the different schemes that we have prepared. We have to research on the site. We have to take out the maximum detail, the physical features, the natural available materials around the site, within the site, or within the reach of the site. We have to analyze everything related. We have to go through a proper discipline of getting the data. I think I have listed about 8 data before the project goes for design. This is according to, it is not according to anybody, it is according to Royal Institute of British Architects. There is a wrong conception with the architects that this is a project management consultancy tool. No, this is a design tool, because BIM starts with an architect and ends with an architect, because he is responsible even for the demolition of the project. So, starting with the data, this is the data 1, then it is the geotechnical modeling. All these details which you evacuate or which you discover will be on the common data platform, will be on the common data platform for the reference, for the information of all other stakeholders. Then the existing condition. This happens through an laser scan or a total station or whatever instrument that is required. Recently, I was in Delhi to understand what is laser scanning. It is an instrument which can bring out at least about 4 to 5 lakh details of the project, the point load of the project completely to the system, so that it can be tailored together to make a proper information about the site. Then we define the site condition, whatever be the site, however it is, whatever is the surrounding, all these details are properly loaded onto the common data platform for the reference of the whole team of all the stakeholders. Then it is space accessibility and circulation requirement modeling. We used to prepare this drawing when we were doing our thesis work. I remember we used to prepare all these details by hand, by sketches we used to prepare. Circulation diagram we used to call. All these details are properly analyzed using software. You see, here what you are seeing is some of the softwares which can help you to make this research, to bring out this data to the common data platform. Then we go through rapid energy modeling. See, whatever it is, we have to tune the design and the project towards maximum autonomy. That is, that it has to maintain on its own for its electricity, for its water, for its air, oxygen requirement. The building has to generate on its own. It should not depend on even on the environment, even for oxygen. We should be able to generate oxygen also within the building. Within the limits, we should be, in fact, we should be generating more oxygen than that is required, rather than taking oxygen from outside. So we go through this rapid energy modeling, wherein all these details, solar energy that can be trapped, wind energy that can be trapped. In fact, in Germany, even geothermal energy that can be trapped will come under data 5 for the project, and it is documented so that everybody will know what are the parameters under which the design has been done. Then comes the lighting analysis, which all of you know. There are a lot of simulations to be done here for daylight, for artificial light proposed, for whatever is the light that can be expected from the surrounding. We go through a lighting analysis. Then the energy modeling, sun studies, daylight, all of you know, climatology teaches you all these detailings, especially sun studies and daylighting. We start in climatology, which we have learnt. And recently, our community is affected, is constrained with Vastu people. They are talking about sun studies and daylighting, which we study as climatology. Unfortunately, they name certain things and sometimes they black night. So anyway, these things are all considered before the project starts, before the design is done. It is mandatory under this methodology that all of you should record, should document all the details that are listed. Then even the interiors and the landscaping. Landscaping is very, very important. Now landscaping detailing will pick up because we are talking about oxygen. We are talking about carbon dioxide. We need these details before we start the design. Is our project self-sufficient for its oxygen output and for utilizing the carbon? We have to ensure. And the interiors, what type of interiors we have proposed, we can propose within the building so that the building detailing will come properly, is decided before the project is designed. All these data put together, an expert panel guiding the client will make the client requirement, which is called EIR, Employer Information Requirement. This is a very important document which will remain for the entire lifespan. This will bind the architect, this will bind the client, this will bind the proper execution, because whatever he expects, guided by the experts, will be documented and he cannot change, or the design team or the execution team cannot disappoint by not providing anything that is written in AR, or anything else that he prefers. Then the documentation would change. the budget would change, the time would change. So EAR plays a very, very important role in maintaining time, talent and treasure, the 3 T's of the projects, which is very, very important because now the world is moving at jet speed. The developments are to be time bound. It cannot be led to its own time requirement as it is. Now a 30-40 building will take at least one and a half year, which is not possible now onwards. We have to think about solutions wherein the detailing will be in such a way that the client will get it for whatever he is paying. Now the design stage starts. After all these detailings that you have documented, considering these as the parameters, you are going to design the building. For this also, there are softwares. Of course, here the architects, the faculty here, and the students here would say that the flexibility gives, because we are using softwares, we may not be able to be creative, which is not so. Actually, here you can also be creative. It will give different schemes. It will give you options wherein you can design, and at the same time you can alter the way you want. And this will be based on the data that you have collected, the data which are defined, the data which is now the guiding force for the design. When you come to this stage, after several meetings in between the stakeholders, there is a clarity on basis requirement of the proposal, based on which where a proper research on the site condition, different options are considered for discussion to select. Considering the different schemes which we used to prepare, the client used to ask, give me 2-3 schemes. It is not like that. Here under the parameter, whatever is defined will be the most perfect. He has to understand how efficient the design is, because it just doesn't come with the software. It comes with the involvement of an experienced architect, of experienced experts who get involved in arriving at this proper design. This is architectural modeling stage, wherein all these details which are considered will be properly defined and will be properly explained in the design, and it is called an architectural modeling, wherein everything is properly simulated, properly proved that every detail is according to the standards, to some standard, maybe finally to the global standards, wherein people will accept it as a proper design, as a proper model. Then it is structural analysis. I don't want to explain much. This is where a civil engineer comes into picture. He will go through all the disciplines required, and all the simulations, all the models that he has done will be properly analyzed, will be validated based on the design output by the structural engineering team. It is very important that it has to be certified by the third party, an expert who need not visit the site, an expert who will get all the data required on the platform that is defined as common data platform, and he will ensure that the design is proper, the design has no flaws. Then MEP and fire protection. MEP is mechanical, electrical and plumbing. All these details which I don't have to explain, it has to be properly analyzed, properly certified, validated by experts. Design team is separate, validation team is separate, including the fire protection. Everywhere we need proper simulations, everywhere we need certification from expert panel. Then it is the mechanical analysis. It is the same thing like in MEP. All these experts who prepare these drawings and details will be properly monitored, will be certified that everything is foolproof. Then the fire alarm systems. Then after all these things are done, after the design is totally completed, we extract the quantity, which is for what? For the budgetary costing, which is the most important aspect of the project. And as you all know, the budget of the project will always keep on changing. because client will change his requirement, architect will get some dream in between, and then all the details will change. So the budget will change. That is not possible when you are under the methodology of BIM. When you are under the process of BIM, this is not allowed. Proper budgeting is done, and within the limits, within a very narrow margin, the building has to be completed. In fact, the budgetary provisions will be such that every day how much money should be in the bank will be also defined by a proper model. That model I am not able to show because hyperlink is not working. If you come some other time, I will be able to show you all these videos. So after all these things, all these design aspects are validated, after the budget is arrived, after the time schedule is also defined, we call this as architectural twin model. It is not the twin model final, it is the architectural twin model before the data enters the site. Before the data enters the site, please understand this is called LOD 200 and it is architectural twin model. My friends, please understand all these disciplines that I have defined out. Will there be any chance for the design to be inferior or is the design to have any flaws? Is there any doubt? If there is, it is a specialty project, a nuclear project or a port project or a railway station project, different detailings are also involved. But after going through all these disciplines, that architectural design twin model that we have done is the most perfect because it is not an individual design. It is not the output of an individual team or a team which is centered on its own. They are accountable. They have to explain. They have to brief, and they have to prove that their design is proper. After all these things are done, it is called architectural twin model. That is the level of detailing at 200. Then comes the class avoidance and detection. This is key strategy according to me. This is my own analogy. Key 1 was common data platform. Key 2, strategy 2 is clash detection and class avoidance and detection. All the models prepared by different experts are put on a single model wherein if there is any clash, if there is any detailing which is not possible, will be detected, will be analyzed, will be sorted out before the project enters the data enters the site. Clash avoidance and detection plays a very, very important role in ensuring the 3 T's, that is time, talent and treasure, being optimized. There is no wastage of time because somebody may not understand a particular section, or somebody may find that running a pipe or running a duct will be not possible only when it is executed. So he has to get back to the design team, then again the drawings has to be redone. So all these details are checked in advance so that time is saved, materials is saved, unnecessary meeting doesn't happen. Then after all these things are done, it is again subjected to model checking and program compliances. These are all certain things which you have to, Solibri is US BIM is one of the, these are the 2 important softwares in which you should be able to analyze these models and get the validation from the simulations that you get out of that. Then the construction drawing production. See, after this model, which is now ready to go to the site, you have to extract the drawing. Recently, I came across with a project wherein there was no paper, there was no print. Everything was in the model. Everybody used to read the drawing. Even the construction managers used to read the drawing on the iPads, on the laptops, on the PCs. But construction drawing production has to be there, and through the model that you have done, you have to extract Like you extract the quantities, you have to extract the drawings also. So all these possibilities are within the framework of the data which are briefed, which are properly explained in the discipline. Then comes the shop drawing coordination. Once, before you start the work, you need to collect a lot of shop drawings because everything cannot be detailed at the design stage itself. There could be certain details wherein you need from the manufacturer the shape drawing, and all these things have to be again coordinated on the main model, on the main BIM model, to ensure that everything is properly defined for the execution to start. Then comes the tender document, preparation of tender document, calling of tender, shortlisting of contractor, selection of contractor, and then the contractor document which will bind the client and the executing agency. Then it is now the in-field construction layout. All these details and data, the drawings, models, everything is now ready on the site for proper understanding, for proper coordination with the workers to execute the work. So under these circumstances, it is the in-field construction, which is in-field construction activity, which is very, very important. And these design models which are sent, which are on the site now, has to be properly discussed, analyzed, understood by people who are on the site. Then comes the scheduling and logistic of construction. Scheduling is, we need to schedule the project. We need to really understand exactly on which day which activity happens, and then also which material has to be on the site. Material cannot come in advance. Material cannot be just put there for months together. Material has to come in time and it has to be used immediately. Then the constructability review and coordination. This is one of the other key factors which has not been listed here. One of the other key factors which happens under the BIM discipline. This is the review. This is called the big room. The people whom you are seeing there are all managers, experts related to design, related to execution, related to facility management. Even the asset managers will be on these meetings, wherein they discuss and decide whether the project execution is happening according to the architectural design model. This is BIM-placed programs, big room activity, which has been already explained, but this is something which will be very, very interesting because I don't have the proper slides to show you the real activities. It will be very interactive session because every detail is properly discussed on the site. Usually big room will be in a container, a 20-foot container, a 40-foot container, where every facility will be there for the meeting to happen, and they just get into the meeting with all the details for proper understanding of the project. Under these circumstances, after all these things are approved, we call this level as 300. After completing all the design process according to BIM standard, consisting of all required detailed design model and simulation, is called design twin model of the proposed project. Then comes the laser scanning. So why this happens is, like, according to the scheduling, according to the details of the project, if on a particular day that activity has to happen, then it can be scanned and ensure that whether the progress is according to the schedule or not, because this can define exactly what has happened the previous day and what is happening on that particular day when it is scanned. So these data will also get into the common data or the CD, wherein all these detailings, or if anything has gone wrong, or if anything has been changed, or anything has been edited, all these detailings would be definitely under documentation. Then the site safety review, I don't have to explain, I don't have too much time. At least this video can be played. this is a very cute scanner which is called actually RoboDog. It is called RoboDog, which will move around the site to take all the details. Because you are all getting sleep, I just thought I should play this loud video so that you will all come to terms. So this is a very cute video which I always like to play in every presentation of mine. This is a very costly instrument, and India still doesn't have even a single robotic dog which can evaluate the progress, which can evaluate even the quality of construction, which can give you all the quantities that is involved, in the progress of the work. So under these stages, we call this as LOD between 350 to 400. I don't want to read. I can give you these details. You can even Google it and find out. Then the documentation. See, every part, every detail, every happenings on the site is properly documented. It is not only the drawing, it is not only the model, it is also the written model which will become a part of the CD that will be generated and handed over to the facility managers or the asset managers. This documentation is a very, very important part of the whole project, wherein the architect has to also go through, has to sign for all the documents which is generated from the project progress, from the project process progress, or the project managers who will be responsible. Then comes the as-built model. This is a very important milestone in the system of BIM, in this methodology of BIM, because this will be almost 90 to 95% virtual to the building executed. Will be a model and digitized model, a computer model of the building that you have executed. You have designed with so much care and you have executed with high preciousness, with proper commitment. This is one of the important stage wherein this model may not go through more changes, and this is called the twin model. Then comes the handover. This complete model will be recorded, will be documented. There is an Excel sheet which we prepare and which we call it as Kobe sheet, and as an addition to the CD or the document that you give to the facility managers, this is handed over with all the details, and the Kobe sheet will contain the location of the files, the location of the model, the location of the detail, which the people who are responsible for maintaining the building will have to understand. Then it is commissioning. After it is properly handed over to the facility managers, to almost the owners, asset managers will also be a part of this meeting. Then the project is commissioned and project utility will start. Then data model integration. So it is after the building is totally executed, automation may have to run parallel to the facility management that happens on the site, because the scanners and the detailings that is required should be only on the completed project. It cannot be done parallel to the project. So during the process of facility management, automation of the building will happen. The building will become intelligent. The building will be able to, the model will become so much intelligent that it may be able to handle the project, handle the building, handle the utility, handle all the problems, all the details that is required for maintaining the project may be handled through the model itself. This model which comes out during the facility management stage, that is after all the automation is done, is called digital twin model at 550 level, which is almost the last stage of the BIM model. Then the facility data integration to facility management. During the facility management itself, there will be a lot of data which are to be again reloaded to the model, twin model that has been used. because there could be, during the facility management, there could be some snacks, some problems, something which will erupt out during the execution of the project or during the utility of the project. All those details will be again re-put into the main model for next part or for the next level, which is the asset management level. This facility management level is called, according to RIBA, it is called 6D level. It is a level wherein the project is properly managed. Project utility happens without any snacks. Then comes the certifications, then comes all other details required for lead certification or any other certification that is required. All the models that you have created, starting from data to the design, to the execution, to the facility management, all these details are submitted to maybe Gruha, maybe to lead. When we were in Abu Dhabi, we used to submit it to Istidama. All these documents, reports, after it is certified, after it is submitted to certify, it is called the 70 level according to RIBA. RIBA calls it as lead, but we can even call it as Gruha or any other certifying agency. So next comes the asset management. After the project is certified by the third party, by the experts, by the people who conduct several analyses on the building, then the project is handed over to the asset management with an approval, with a certification from them. It has come through the proper design process, properly executed, properly maintained, and it is according to the EIR. EIR is Employer's Information Report. If it is, everything is according to the report or the understanding which was entered at the starting of the project, then it has reached the level of 70 according to RIBA. So these are the different stages which I have already explained to you, which I am trying to just conclude, which I need not explain again because there is lack of time. Mr. Vasant has told I have to complete the presentation within 1 hour. So I am trying to highlight. These are all the beautiful videos which I have got. I am playing very minimum videos. I am not able to play all the videos because of the lack of time. But anybody interested can contact me, or I can come back to you again to play all these videos. These are all again the conclusions and the detailings which I have explained. I think I have explained to you properly. These are all again, this is a video which I request all of you to be very attentive on this video, which is very beautiful, which I got it very specially from somebody who selected and gave me with lot of precaution, and this video is very beautiful. This is almost a BIM model, which is not with many who are presenting. This is a very beautiful, I'll play this completely. Please be attentive on this. Furniture detail. Specification is also defined in this, which you have to carefully understand, and you should be able to read even the specification of even the walkway. the time is almost over, so I'd like to rush up on the presentations because I have about 100 slides, and these are all some of the uses which I have briefed already, which I need not elaborate again, and these are all the possibilities which you can get in through this BIM when you use it as a proper methodology or a proper process to end up with a net zero project. So these are all some of the utilities of the efficiency, class direction and coordination to minimize the coordination errors, asset management, improved client. This is one of the important graphs which all of you have to understand. This is called the economic benefit of implementing the project. This here you are having a graph wherein it clearly defines the utility of the of this BIM methodology. When you execute the project, when you decide on the BIM project, you are going to spend little more money on the experts, little more on the consultants. But when you come to execution, when you come to the maintenance, when you get it as an asset, the utility of the project will be of very high magnitude in terms of money, because you need a lot of experts to go through the discipline of the design and to execute accurate execution of the project and to ensure proper maintenance of the project. So even if you spend more at the initial stage, as the building is maintained, you will recover that money, and that will be too much compared to the actual project without BIM as a discipline. These are all to be explained. It may take 1 hour for me to explain the complete detail, but I would like to end up. These are all the utility. The 17 sustainable goals will directly get benefited from this methodology of BIM. It will directly be helped by following BIM as a discipline. Then to make cities and human settlement, Britain, UK has made BIM mandatory, and the whole country is getting digitized. The whole country, I'm not talking about building a project, the whole country, the metros, the railway system, the roads, everything is now digitized by Britain. And the consultant who has done that for Britain has been given in charge of also Australia. And we knew that, we have him on the group, but it is something that we should know that all our cities, if you come to Bangalore, all our wards have to be digitized like Britain as a country it is digitized. Anyway, it is a long way to go for India, and let us see. Sustainable cities and communities, these are all the projects which can get the proper benefits, the slum dwellers, and the other part of the cities or the villages or whatever it is will get directly benefited because of the efficiency of the project, because of the accuracy of the project, because of the maintenance, comparative maintenance without BIM, how the project is maintained, it will be the benefit you will see only when you use BIM. So these are all the software involved for getting the BIM process in place, for maintaining BIM as a methodology. So anyway, all these details needs a lot of explanation, but I would like to give you one clue that while selecting the softwares, please be sure that the software is open software against closed software. Because I don't want to name the vendors, because we are on live. I don't want to blame anybody. The definition of open software is that it can mingle with any other vendor because some of the consultants or the specialists may be sitting in Europe. There they may be using different BIM software. We may be using different software. If both of them have to be on the common data platform, they have to be open software, wherein whatever software, whatever models that you have created, they should be able to open, edit, and also modify and also put their recommendation. So ensure that you are using an open software. There are some vendors wherein if you stick to them, you will have to use their own softwares, without which they will not be able to read. This has created a lot of problems in practically executing the projects. So please be sure that you have to use open softwares in selecting your softwares, and it has to be also economical. It cannot be costly. There are some softwares which are even which are between 5 lakh to 10 lakh. There are softwares which are about 3,000 to 4,000 rupees per month, which you can cut after the project is, if you have completed your services, after 3 months, you can cut the project, you can cut the software. Such softwares are there. Anyway, you can research and you can ensure that you are buying an open software and which is also economical. Present impact of BIM and AECO project. See, in India, we have only Airport Authority of India, metro projects, railway projects, defense projects and irrigation projects which are mandatory. And India is producing, is manufacturing 2 crore people every year, and between 15 to 18 years, the population of one USA we are producing. Considering this, India has to be more faster in executing these projects, which are to be more accurate and which has to really match with the population that is uncontrollably increasing. So government role, what is the government role? Government should understand and use BIM as a tool, which is not happening. India, all other countries, many developed countries have made this mandatory. Many other countries have made it a rule that you have to use, whether it's a private project or a government project, infrastructure project or any other project, you need to use BIM as a tool, BIM as a methodology. But unfortunately, Indian government has not yet taken that step. It is slow, but the demand is more. And India is promising net zero by 2070, and China is promising in 2060. Some of the developed countries are promising before 2050. But unfortunately, India has to be very, because of the mass, because of the cities, because of the villages getting converted into cities, agricultural land going out into cities folds. We need to be more considerable in enforcing BIM as a tool. Role of architectural colleges. Please introduce, I request Vasant Bhatt to introduce BIM within the syllabus to ensure that the students who are our future architects, who are going to be the leaders for all these kind of projects, should know the methodology, not only the methodology. So in each semester, some of the software also has to be taught, because it is high time that other countries are having a separate faculty, separate subject as BIM for the student. In India, BIM is never taught in colleges, is not considered at all. Still, at least the percentage is very, very low or negligible. So the role of 1,55,000 architects. Morning, my friend Salim corrected me. The number I thought was 90,000 architects. We have 1,55,000 architects registered under our architects architects team or the faculty, and we have about 10 lakh civil engineers. So what is the role of architects and engineers? Learn and strategize to give BIM services. Please understand that we have to be volunteer. Right now, there is no mandate. It is not mandatory, or it is not taught, or it is not a habit at all. We have to make it an habit by learning it and by giving the BIM services to our clients. Conduct BIM awareness program like what I am doing now to stakeholders. Your partners who are working with you should also know. If not, if you alone know, it is not enough. You have to share this information. You have to share the benefits. You have to share how the project will be better by using the BIM methodology. So now I am going to come to the most important part of this presentation, because 99% of the people here would like to make money, would like to see money, would like to get into this properties, cars, and whatever dreams they have got on their own. So by this presentation or by using BIM methodology, what are the different benefits, what are the different services that you can offer to general public, I have listed here. About 76 different type of services you can give it to the government, the general public, public sectors, or whatever it is. Each business BIM use means each case that we have discussed is a service which can be used when you learn BIM as a system, because this is also money. Once you learn, once you get into all the equipment, once you are equipped, you will be able to generate nearly 76 different kinds of services to your clients. So investment required, don't be too much worried about the investment that is required. You can, if you are strategic, if you can analyze, if you can really understand, you can go with the most minimum, and each one can become an expert on its own. These projects can be handled by, these BIM projects can be handled by MSMEs. It is not that you should have huge money. Huge money is different, it's a different level, but an ordinary person with least money will also be able to give the BIM service. Our strategy as a community of AECO, anyway, this has been already discussed, and I think I would like to come almost to the end. And BIM is something that is not available as a course in any college. I learned this BIM in the National BIM Society or India BIM Association, which taught me continuously to make me understand. And we have a group of people who are interested in learning together, in sharing it with people, in sharing it with our future generation to understand what is BIM. So you can Google and find out and get into these this association, which is very, very active, which is an NGO wherein everything is properly made to understand. In fact, I am reaching my 60th end of the month, and at this age, I have been able to understand BIM. And I was telling one of my friends that BIM is not something which is seen to be like very technical. It is not. It is just that we need to go through the disciplines and understand this subject of BIM. And I am a part of forum. It is a critical utility services forum wherein experts in the field, national experts are with us on this forum for us to share the information, for us to understand what is happening, and for us to share our business, share our detailings. We have formed this group. There is an entry for students also. Only 500 rupees has to be paid to become a member here. You will be meeting the best of the best structural engineers, best of the best architects, best of the best MEP experts in this forum. In fact, V. Suresh, the HUDCO, who was the HUDCO chairman, is presently the chairman of forum. I am the vice chairman here under BIM. So we are trying to, I think I have come to the conclusion. Now I'd like to ask a question, like what is architecture now with BIM? Architecture is defined, everybody knows, and I don't have to ask the question. Now I ask you a different question. What is architecture now with BIM? Can everybody stand up and enthusiastically answer my question? What is architecture now with BIM? Faculty can also answer my question. What is architecture now with BIM? Okay, anyway, you think over and understand. Please be sure that there is no other way that architects have got to ensure that we deliver quality projects to this world. My motivation for making this activity is my motivation to motivate students, teachers, decision makers in the government related to ACO field about BIM towards global standards, to serve all the 17 SDG goals and also to achieve maximum net zero building and projects so that global warming is controlled. This is the motivation with which I am making this kind of presentation, to ensure that our future generation get a brief and they understand and they try to follow the system, the methodology, which is very, very important for our, at least the next generations to come as architects. Now it is the end of my presentation. I'll open for discussion. I know I have very less time. I know I have taken more time than what our principal had told. It was that just that I had many more videos to play, and I have tried to cover everything that is required within the limits. Any questions? Any questions? If there is no question, can we end the session? I think you are all waiting to end the session because I have taken more time. Thank you very much. Thanks to our Vasant Bhatt sir. Thanks to Vasant Bhatt sir for giving me this opportunity to share what I know about architecture and what I knew after I became an BIM, after I was educated with it. Thank you.
Thank you, sir, for your valuable words. I hope everyone present here would make a use of it. I now welcome Mr. Kundan Dige, Associate General Manager, Product Development and Sales, and Mr. Yashas, Assistant Manager of Veena Berger, and I request Senior Faculty Usha Ma'am to hand over the token of welcome to the guest. Upcoming is the talk by Mr. Kundan Dige to introduce their materials to the students.